What if I told you that every distributed system has to make an impossible choice? Imagine you are checking your bank balance. One server says 10,000, but another server still says 15,000. Which one do you trust? This impossible situation is exactly why CAP theorem exists. Stay till the end because I will also explain why CAP theorem is not the full story and why companies today use something even better called PACELC. So when your application runs on multiple servers, keeping all of them perfectly synchronized is extremely difficult. CAP theorem says that distributed system can only guarantee two out of three properties: consistency, availability, and partition tolerance. So let's decode them. Consistency means every server always returns the same data. Suppose you transfer 5,000 from your account. No matter which server you query next, every server must show the updated balance. And if one server is showing the old balance, the system is not consistent. Think of online banking. You definitely don't want different balances depending on which server answers. Next is availability. It means every request gets a response. Even if one servers are having problem, the system never leaves the user waiting. So maybe the response is not correct or latest. But you always get the answer. So think of this library example. It has multiple branches. So if one branch have not received the updated results, it can still tell you yesterday's inventory instead of saying sorry, come back later. And third is partition tolerance. Now here's the tricky one. Imagine you are connected with a network cable between servers and it suddenly breaks, right? So the servers can't connect anymore. This is called network partition. Should the entire application stop? Of course not, right? Partition tolerance means the servers keep working even when the communication fails. If they can't talk to each other, so who has the correct data? So here's the most people misunderstood. In modern distributed systems, partition tolerance, this network partition is not optional. Network failures will happen. So the real choice is not between all three, right? It actually becomes consistency or availability, right? So we have to choose which of them is required because partition tolerance is not an optional. So if you choose consistency, the system would rather stop serving requests than give you the incorrect data. So what it will say that if I can't guarantee the correct answer, I won't answer at all. And now this is what we call the consistent plus partition tolerant system called CP system. So we have examples like Apache Zookeeper, MongoDB, Redis cluster, HBase. So they have like this consistency shield and they will always give you the correct answer. Next, we have the AP system. So if you choose availability, the system always reports, even if the data is slightly outdated or it may be incorrect. Eventually, all servers will synchronize, right, and become consistent. And this is called eventual consistency. Examples we include like DNS, Cassandra. So they all are the AP systems. Perfect when staying online matters more than having the absolute latest one. So can we have both consistency and availability? Yes. So if you have only one database servers, for example, in case of MySQL server, since there is no network between like multiple nodes, like they are already running on one node, so there is no partition to worry about, right? And that's why these traditional databases like MySQL or PostgreSQL can provide both. But once you distribute the data across multiple machines, CAP comes into the play. Think CAP solves everything? Not quite. There's another theorem called PACELC. It says that even when there is not a network partition, you still have a trade-off between latency and consistency. So want stronger consistency? More servers must acknowledge every write, which means higher latency. So, distributed systems are not just choosing during failures, they are making trade-offs every single day. So, remember this simple rule. Consistency says always the correct data, so it helps in the correctness. Next is availability. It says that always get a response. It talks about the uptimes. And partition tolerance says systems survive if communication fails, network fails, and because partitions are unavoidable, distributed systems usually choose between two like consistency or availability. This finally made CAP theorem click. Hit subscribe because next we will cover some more tricky concepts of system design.